I would like to start telling you a story. And it is a story about a couple who met and found their way in life. Many extraordinary tales have been told about this couple. Like their origins in Oahu, one of the 8 islands in the Hawaiian archipelago. Many moons rose and fell, and shiny rainbows would ascend to the sky after the tropical rain. Probably the same ones Captain James Cook sailed past the island back in the day. Their love was bounded by the jungle air and the salty breeze, 2 foreigners in an island looking for adventures, freedom, and a sense of purpose. But this is not actually the story I'm telling you today. The story I'm telling you today is a story about how this couple moved to Hamburg and they pursued to start a business venture. This couple founded a sustainable clothing label. They both had a passion for sustainability and for style and for fashion. She already had some history as a seamstress and garment maker. He was inspired by his seamstress grandmother, who used to sew him gardens according to the epoch. From color neon suits inspired on Miami Vice, to neon color streetwear inspired by the Fresh Prince of Bel-Air. And they bootstrapped this business, and they were strapped on cash. So cash was very short, and it was very hard to find an affordable agency who could do an online store for them. Until one day, they found an agency who was willing to do the online store for them for a very affordable price. At the time, it was development only, so they still needed to prepare some screens for this store. So with little to no knowledge, they prepared some screens, and very surprisingly, the agency liked the designs a lot. And you have to consider that until that moment, this guy had nothing to do with the web, nor computers. He didn't even have a high school degree, for that matter. And, that was too soon. One day, the agency owner told to this man, he had this wild idea. And he said, I think front-end development would be something that you would really like. What if you start helping us develop this store, and you will learn web development as a payment for our services? The man knew this was a one-in-a-lifetime opportunity. And of course, he took it. And since then, he never looked back and never expected to change his life in such a profound way. Web development and programming became not only his work, but a passion that drives him every day to pursue new things. My name is Mauricio Palma, and that was the story how I became a web developer. And today, I work with my wife. We run Wood Like Ocean. It is a swimwear label where we craft swimwear out of ocean-recovered fishing nets. And what we do, we have the possibility to experiment with using waste as the main ingredient of our products. I'm also a product engineer at Sinna, a German agency, where we get to work on some very exciting projects from some very big brands. And my favorite is when we get to work in open source projects. We have some of them in-house. And I love open source projects. They're the most fun. And so far, you might be wondering, why are you telling me this story? Well, I bet a lot of you in this room are self-taught developers. Raise your hands. Self-taught developers? That's a bunch, almost half. And if the web wouldn't have been an open place, then learning web development would have been very, very hard. Now, if you're still young and you don't remember how it was things before the internet, then I invite you to ask your parents or your grandparents how things used to be back in the day. And for many of us, it has not only been a path to find a career. For many of us, it has been an opportunity to get out of financial distress or to get out of poverty, an opportunity for a better life. And this is the very nature of the web, an open space for everyone, an open space for creativity, for collaboration, for invention. Yet, when we don't implement accessibility, we're excluding people, we're excluding communities, and we prevent web technology from growing. And a lot of the times, or the problem is that we use our own abilities when we're developing or designing websites or web applications. And it's not good, it's kind of our human nature. We tend to avoid things we don't understand. It is part of our human nature, but by doing so, we end up excluding a lot of users. So once again, thanks very much for coming to this talk. You can read this sentence I'm calling it, and we will cover how can we use accessibility as a core concern of the application. And let's go over the agenda, right? So, es muy importante tener en consideración que implementar accesibilidad puede ser muy difícil. That was awkward, right? And now tell me, how many of you understood what I was trying to say or could read the content I just read? So I want us to try something out. If you didn't understood what I was saying and couldn't read the slides, please stand up. I want to show you something. You will see the point. Stand up. Now look around. Look around. Thank you very much. Now you can see it. So the point is, you may be, let's reflect for a moment. And when I was speaking Spanish and showing unreadable slides, maybe you felt irritated, maybe even anxious or angry. Sorry. And this is literally what we're doing every day to people and the web. We are excluding them. And that's what we're doing to about 217 million people with visual impairments. We deny them access to our professional and personal lives. And what if I can tell you that exclusion literally hurts? Neuroscientists have discovered that the feeling of pain, how our brain processes, is the same as the physical pain. So being excluded literally hurts. And there are, like I mentioned, about 217 million people with visual impairments around the globe, of which 36 million are blind. In Europe alone, there are about 30 million people with severe visual impairments. And the truth is, as developers, we don't think very much about these numbers. And this reflects pretty much in all these applications or interactions where we are excluding people. But how are we supposed to fix something that we don't know? And that's why we will cover first we will simulate some of the known visual impairments and their implication in the web, for you to have a better understanding of how users feel or experience the applications and the sites we're developing today. So blurry vision, when we talk about it, it is the loss of eyesight. It makes an object appear out of focus and hazy. And I have some key takeaways before we get into the automation part. And it is, remember always to publish your all information and content in the HTML. So a lot of us are doing a lot of JavaScript nowadays, and we tend to forget how important it is still the HTML that we're rendering. So remember to publish all information there, to use semantic HTML, and to use the according area landmarks, write screen reader-friendly markup, and provide keyboard navigation. There are different types of visual loss, and several diseases cause, or eye damages caused by several diseases. And by no means I am saying this is the only way people with visual impairments experience the UIs. But this is a pretty accurate simulation. And when we talk about partial vision loss, we talk about peripheral visual loss, also known as tunnel vision. So besides the mentioned HTML, semantic HTML, and screen reader-friendly markup, you should always follow a linear logical layout that supports at least 200% magnification. Central visual loss relates to when only side vision remains from the side. It is when your eyes focus straight ahead, allowing us to read and make very important decisions. It is the central visual covers around 5 degrees of our visual field, and it allows us to make us very important judgments, like estimating distances or recognizing details ahead. Now, always put your form elements in context, meaning putting buttons, notifications in a logical manner, and for action elements in your interfaces, use a good combination of colors, of shapes, yet don't use color for convenient meaning. Dyslexia is a common learning difficulty and can cause problems with reading, spelling, and writing. It is a complex language problem, and it involves not being able to break down a word into the sounds that it makes, and not being able to think or write about the sounds of a word. Now, reading or writing are among the most important prerequisites in our society for success. And yet, according to the European Dyslexia Association, and this is a beautiful statement that I think should apply to the web, every person with dyslexia has the right to access and receive appropriate support and opportunity to achieve their full potential in life, in work, and education. So some key takeaways are: align your text to the left and keep the consistent layout, keep your content short and simple, considering producing other kind of materials like video or audio, and let the users change the contrast between backgrounds and text. Now, color blindness is a visual impairment where people lose their ability to distinguish colors. In this case, what we see on the screen, it is protanopia, which means a problem with the red hues. There is, you must apologize, this is a hard word, it is deuteranopia, which means no green hues. Then we have tritanopia, which is blue-yellow hues, and monochromatism, where the person perceives colors like different shades of gray. Now, very important, don't convey in color to provide meaning. And implementing accessibility for people with impairments seems like a significant constraint, but the resulting web application can actually benefit a lot of other users as well. By developing solutions for people with visual impairments, we help other users, for example, with temporary disabilities. For example, what I'm showing here, it is bad sunlight or the screen glare in your phone. And remember that disability, it is not just a health problem. Disability is the inability to interact with your surrounding environment. That means that physical, cognitive, and social exclusion is a result of mismatched interactions. That is why we talk nowadays about the persona spectrum, covering a range of permanent, temporary, and situational disabilities, meaning a person can be blind, which is permanent. A person can suffer from cataracts, which is temporary, it can be cured. Or, for example, a distracted driver. He has a disability too. And for us developers, it means that we can use technology as a means to come up with solutions that include more people and the applications we're writing today. And you know what? What if we put accessibility everywhere? Not only in the underlying UI UX, which is awesome, by the way, if you're doing that already, but we can propagate accessibility in many of our software layers. And for example, let's cover a few. It all will always start with you, the human aspect of software, the mindset. It is the link between your computer, so it would always start with you. But then we write code, and we write some features, and we provide accessibility in the application in some way or another. And then we write unit tests, and we want to be sure that we are being compliant to the accessibility standards, so we can use them in our favor. And of course, we want to know that our functions are returning the expected value. And let's put it in our build pipelines. Let's check as much as possible that accessibility is being implemented. Now, it is like a sleeping insurance. How many of you are in charge of shipping some deployments? Raise your hands. Good. Now, do you know the feeling when you're deploying on a Friday night? I guess that's how she's feeling probably too. So now we're getting more into details. We're here to talk about color contrast automation. And the whole idea of this talk came to me as one day I saw one of our designers checking for the AA and AAA color palette of a corporate identity. And she did that manually by checking every color, one by one, checking if she finds a contrast match. And don't get me wrong, she created this beautiful color contrast accessibility chart. She did an amazing job and created an amazing documentation. Nevertheless, it just hit me like a rock. And this is error prone. And I know I'm talking about a person, but if we talk about her performance of manually checking every color and we compare it with time complexity, that means that that would be n squared. Meaning, if you have something like 50 colors, you would end up, in the worst case, with 2,500 iterations. Now, you can do this on software too, by the way. So if you do it with a linear search, you will probably end up with the worst case as well. And that's why we will cover how to automate color contrast in the most performant way. And that's how I created this little project called Forward. Like, if you know MVPs, probably this is the MVPs of MVPs. But it works, and it will help us a lot to demonstrate how to implement something like this. And basically what we will do is upload a color palette, check all the colors automatically, and then deliver all the AA and AAA color contrast combinations of this color palette. It is not so important, but I guess people are always curious what I'm using under the hood. It is a universal JavaScript application, and I'm using Next.js, TypeScript, React, and Emotion for styling. Now, the implementation heavily relies on the guideline 1.4 from the Web Content Accessibility Guidelines. It means we will need to provide AA and AAA color contrast combinations. Now, are you familiar with the terminology of AA, AAA? No? Okay, we will cover that. A AA, and AAA are 3 levels of conformance defined by the Web Content Accessibility Guidelines. So these are pretty much the standards we're going to be using in our benchmark to see that we are actually providing accessible color contrast. And when you take a look at the Web Content Accessibility Guidelines and you implement them in your project, you will provide more accessible web content and more usable for the users. That was kind of not properly said, but anyways. Color contrast, AA means a minimum color contrast would be a contrast ratio of 4.5 to 1. That's the minimum color contrast. The enhanced color contrast or AAA color contrast is the contrast ratio of 7 to 1. Now, there are some exceptions. For example, large-scale text. So large-scale text can have a color contrast of 3 to 1. AAA would be 4.5 to 1. And we would define large-scale text as roughly 24 pixels or 19 pixels bold. Other exceptions as well is like for the Web Content Accessibility Guidelines, logos and brand names, they don't need to provide this color contrast. But if you're a brand or a brand manager, I doubt very much that you want to do that. And inactive UI elements, like hidden elements, or elements within a teaser with a lot of pictures, do not need to be compliant to the color contrast. And checking enough color contrast between text and its backgrounds allow people with moderate low vision actually read your content. And people with color blindness might even perceive the UI differently because color can affect the luminance of the provided contrast. So now we will cover the first steps how to do this. And this is the calculation you will find in the Web Content Accessibility Guideline. You can take a look at it for a second. I will drink some water. Now, when I first read this, I was like, excuse me? In my opinion, the information was not so easy to read. Everything pretty much in one paragraph. And that's why I want to break things into smaller steps. The concept of color can be divided in luminance and chromaticity. Luminance is a photometric measure of the luminance intensity of unit area of light in a given direction. And it is worth to mention that objects don't have any color. Like the objects reflect light that seems to appear to have color. So color only exists in the mind of the beholder. And relative luminance is pretty much the calculation that follows the photometric definition of luminance with a normalized value from 0 to 1. 0 being the darkest black, 1 being the lightest white. And to calculate the contrast ratio, we need to calculate the amount of relative luminance for the sRGB working space. Now, sRGB stands for Standard Red, Green, and Blue, and it is a standard that was created back in the day by HP and Microsoft back in 1996. And it was later standardized by the International Electrotechnical Commission in Geneva. The whole idea, or it was designed to represent colors in the same way across different devices. Because the sRGB has a very small color gamut. Gamut is like the subset of colors available. So it is like 8-bit colors. But it can be reproduced accurately in almost all devices. And sRGB, even though it is over 20 years, sRGB is still the standard for the web. And an interesting thing is that our human visual system works very similar to the RGB color space, meaning that we have 3 independent channels to convey color. And we have 3 different kind of cone cells that process this color. And that's why we will be using RGB as our base for the calculation, because of both reasons. Now, chromaticity defines the quality of color regardless of its luminance. And it consists in 2 parameters. First, we have the hue, or dominant or complementary color, and the saturation. In the XYY color space, the lowercase x and y represent the chromaticity, which we just mentioned, while the uppercase Y coordinate represents the luminance. And this number of parameters follow pretty much to the form of trichromatism, which, as I mentioned, is the way our visual system processes colors. So we will initially put everything on an enum just to represent our intent. And what we want to do is divide each entry of each primary color by its full intensity, which is 255. So we will check if the value is less than 0.0392, and then crunch some numbers further. On the second step, we will get those values from the luminance for each color space, and we just add them together. And that's pretty much it. This is how we get a normalized relative luminance, which we can use for our color contrast. And for the color contrast, it's good to mention, in case you want to implement this in the future, it is important that you always follow the same operation, meaning you always want to divide light with dark. And that's why I'm always checking which is the light, which is the dark. And that's pretty much it. That's the algorithm you need to calculate color contrast of 2 RGB colors. So the next step for us is to process the colors and find in a performant way all the AAA and AA combinations of a color palette. And we want to be agnostic about it. So we don't care if we're running this program on the client, on the server, on a build pipeline. So it is important for us to follow a performant way to implement this. Remember, I said accessibility everywhere. So our first step, so we have a color list. Our first step would to do a quick sort, which is considered a fast sorting algorithm that takes the divide and conquer approach. And it is a principle used in many complex applications like a file search or data compression. And basically, that's the implementation of a quick sort. We are comparing each color entry with the defined color pivot. We do that by providing the luminance function that we just created, and we will give it as a second argument. And when we compare the pivot against the lower and higher entries with the partition function. And this will be returned by the function as well. And our pivot divides the array in 2 halves. So picking a good pivot when you're implementing a quicksort, it is essential for a fast implementation. But for now, we will just go for the middle element of our input. And this is basically how we do. So we are breaking down the problem into smaller problems. We have the pivot, we have the lower and higher ends, and then we start checking. And at this point, I'm intentionally swapping the array elements. So I'm not creating a new array. I'm swapping the elements because I'm considering maybe I could have problems with memory allocation. And pretty much the process continues until we have sorted all our colors and end up with the list sorted from 0 luminance to 1 luminance, or from darkest to light. Well, sorry. So the second step would be for us to do a binary search. So we have a sorted array, and now we can find the AA and AAA color contrast. If you're not familiar with a binary search, you have to take in consideration you want to use it only when you have a sorted list. And the reason for this is that binary search assumes that the middle of the array contains the median value. And this is pretty much how it works. It compares the target value with the middle element of your array. If the target value is greater than the middle element, we eliminate the left side of your array. In that case, we continue the search on the other half, and we repeat the process until we find a match. It could be possible that your array don't contains the AA or AAA contrast ratio at all, and that's why I included some other things to it. So let's elaborate a little bit more into that. In our search, I'm including two new content. A preview value, which is on the left side of the mid element, and a next value. So basically what I'm doing, I'm checking if the value could be possibly within range of the array, and if it is greater than 7, for example, if we're checking for a AAA value. And basically that's what I'm doing there. So now we have a sorted list. We know all of the AA and AAA color combinations. We could create some kind of object that contains all the information for us to use later. And this is a simplified factory function where we have a name, we have a list of all AAA colors, a list of all AA colors, and why is this good? And it made me think a lot. I've been living in Germany for the past 12 years, and German sayings are kind of funny. And there is this one, im Griff haben, which means to have under control. And that's what we want to do here. We have to have control over the colors provided. So we cannot only use, for example, we can use this with our designers. We can sit together, we can check the colors, and we can tell them these are the color combinations you can use. You can use it directly in your software. I mentioned I'm using a universal React application, meaning, for example, I'm putting it on the theme provider, so I can use it on my styles already. So I can propagate it pretty much everywhere. And I have a small demo for you. So this is the project, and once you upload the color palette, for example, these are 32 colors from an imaginary color palette, but it could be the color of a CI or of a company. And then at this point, before I even render, the software already knows about their AA and AAA color contrast combinations. So for example, if we go to Lucky Point, then we know that in this given color palette, these are the provided AA color contrast ratios with the ratio as well. So white works very well, and Mandarin sorbet works okay. And then for AA, the same. And that's pretty much useful because, like I mentioned, not all colors will have a AAA or AA color contrast. So in this case, this color has a funny name. The Eye of Nude has no color contrast combination. So it's going to be hard to use it, especially maybe it is our color for our error. So what do we do there? At least we know it does not work with any of the colors we have there. And that's pretty much it. And like I mentioned, it is still very MVP, but it is open, so you can play with it. You can make it better, or you can break it if you want, or experiment with it. So I'm very happy if you want to help me with that. Maybe make something more meaningful than just with designers checking, or anything that you can imagine we can do with that. And so we had all this talk about accessibility, about why it is important, and maybe you're thinking, but what are the real benefits? Well, first of all, by designing and developing web solutions with accessibility in mind, we generate fresh and new ideas, and we can provide elegance and utility for many people. And it is a win-win situation. So what if I can tell you studies have proven that an accessible web page, people are willing to spend more money on a web page that it is accessible, even if it's not. They are willing to spend more money on an accessible web page. That's what I meant. And on the other hand, Europe is becoming more aware about the importance of openness, inclusion on the web. And for example, in Norway, it is illegal for a web page to be inaccessible. It doesn't matter if it's the public or private sector, a web page must be accessible. So at some point, if you're creating or working for other countries in Europe, then you will have to do it because of legal compliance. And I thought I could mention, a lot of people ask me, okay, but how much does it gonna cost me to implement accessibility in my application? And unfortunately, I don't have like a golden rule I can give you about how much it's gonna cost you. And it really depends on your project, on your requirements, on the legal requirements. But what if I can tell you that when you start incorporating accessibility, you will definitely need to invest acquiring knowledge, establishing processes, and manage the increased developing time that we need. That's an investment that we will need, and testing as well. But we can put an imaginary number. Let's say that the initial effort of actually implemented accessibility, it is 10%. It's imaginary. So we know the requirements for these projects is going to cost us about 10% more. What I can tell you is that if you're working on a project and suddenly in the middle of the project, someone decides, by the way, we need to be accessible now. So I can tell you that's going to cost you at least 100 times more than what was expected to be spent on this project. And I have lived that. It is very painful. But the worst is when you're done and someone in the management layer says, okay, now we need accessibility. But the project was already launched. So I can tell you, you better start from scratch. Probably that's going to be cheaper than trying to implement accessibility on a project that is almost finished. And so I guess we have a lot of time for questions. 50 minutes. Perfect. Thank you.
Who has a question?
Hi. Yes, thank you. I have a question. How to measure the accessibility of an existing site?
Sorry?
How to measure the accessibility of an existing site?
Well, there are many tools, and I will try to include some references to the slides. But there are, if you're working on a node project, for example, there are some packages which are some modules which are doing testing for you already, for example, for the build pipeline. There are some things you're still going to need, for example, like a quality manager that checks for screen readers. So it depends what kind of accessibility you're implementing. For example, keyboard navigation, then you will need a quality, someone that do a quality control for it. But like I mentioned, there are many modules that you can use for your build pipeline that will already check things for you. I hope that helped you.
Can you show some example or a name of a utility for this?
I don't have one right now on the name, but I will put that on the slides.
Okay, thank you.
Definitely.
Okay. Thank you a lot.
Yeah, thank you.